Morning, everyone. My name is Tushar Puri. I'm with Pegasus One. We provide healthcare solutions to payer, provider, and digital health companies. I was supposed to be accompanied by Andy Rieger from Transparent Health Group, but he could not make it because of the bad weather situation in New York area. So anyway, we initiated this zero hold time forever project with Transparent Health Group. Uh, which we then extrapolated to zero callback forever, which at that time felt to some extent audacious and maybe even little irresponsible. Uh, but while implementing this solution, we realized the biggest friction was around the data, not the complexity of AI and everything around it. And we know friction gives rise to anxiety, callbacks, and burnout for call center employees. So the way we ended up measuring our success was not just around the prediction of our models or the accuracy of its ability to be able to understand, but about the human experience, how much it's able to bring down the anxiety for our members and callers from provider networks. When we did our analysis on the calls we were getting, we saw most of the calls were pretty routine calls, which could be just pulled up from database, straight lookups, as long as the data is fresh. And of course, the call center typically is available 9 to 5. Cost ranges anywhere from 5 to 10, $12 in our case at least. And if you add up the callbacks, it just doubles up. And little to no automation, at least in our scenario. Uh, so we ended up always questioning why are humans doing the work which can be easily automated. Overall, it's not a great experience for our members. Say somebody got a bill for $5,000, rather than waiting for the next business day to call up and get a reason of why they got the bill. They would rather call in an automated center and get the proper resolution to their challenge. So our key success factors for these projects were, of course, zero wait time, which then we extended to zero callback. And to achieve both of these factors, we needed to also bring in the aspects of uh, building a layer around the history of the caller. So we can look at the past trends of the caller, look at the past challenges caller may have run into in the past, and also ability to bring in context of the caller, any claims which may be in process, any issues which are still not resolved. So AI can provide proactive insights to the caller. So here's a sample call. Say Maria is calling from Dr. Jones' office. She called up about a claim essentially to just get an address. But AI was able to proactively look up, hey, there are 3 claims in process which are likely to be denied because it's just missing a rendering and NPI. So it proactively mentioned that here's the address, but by the way, these 3 claims are likely to be denied if those NPIs are not provided. So I can send you the text or email so you can fill up the form and resubmit the claim. So overall, it reduced the future callbacks uh, for the claims which would have been denied. So this was our high-level architecture for the application. On the left side, you have all the fragmented data sources such as claims tree, eligibility systems, provider registry, and then in the center aspect, you have all the compute and or AI layers. We had FHIR for all the data access. We had semantic normalization for translating the terminology. Then, of course, the response generation to be provided back to the member, and then intent recognition to understand the reason why a caller might be calling, and then history and context just to provide more rounded reply to the caller, and of course, finally routing the consolidated reply to the output mechanism to figure out whether it can be handled by AI or it needs to be escalated to a human being. So one of the design consideration we had was around adaptive response. So based on caller's vocabulary, the tone, and the speed which they're making the call, our system is supposed to change the response it's providing. So as an example, if you're getting call from a provider office, from a billing agent who has been in the industry for a while, he will just call up and say, I'm calling for Smith Jones and we submit the claim on 2 weeks back, what is the status? In this case, the caller expects a very direct and succinct reply. So AI can look up into the system and say, hey, it's missing modifier 25, and then I can send you the detail to resubmit the claim, otherwise it's going to be denied. Similarly, if you get a call from, say, Carlos, who is calling to a claim center for the first time, he got a bill for $5,000 and he's not sure why he got it. Now this person need a well-rounded reply which he can take it further. So AI system will provide, looks like your doctor has not provided details for one of the diagnoses he did, so it's likely it has been denied, but I can send you the information which you can then take it to your doctor to resubmit the claim. So basically it's not about the information you're providing. In both of these cases, we ended up providing the same information, which is essentially the reason for the denial, but the way it was delivered was way more important and finally would reduce the callbacks for our call centers. So it's essentially about not the information but the delivery. Oops, I forgot to move the slide. So these are the examples I was talking about, based on changing the delivery of the same piece of information based on the type of caller who is calling. So latency aware design was another important criteria for us. As much as we all know that data is important for AI systems, but we also know if data is not available, because we know not all the information is going to be available in real time. Some information may not be available for a few days even. So we need to bake in as part of our reply to the caller. So as an example, if a caller calls up for a status which was only updated 2 days back, instead of AI system telling, hey, your status is still pending, it should rather say, as of 2 days back, your status is still pending, but by the way, it could have changed by now, and I can re-inquire that information source and text you the information or email you the information when I have the detail. Because we know if you just give them the status, it will trigger further decisions and overall increase the anxiety for the caller, and he might end up escalating the case or may end up even resubmitting the case. So we probably know healthcare ecosystem is very dynamic. Data keeps changing, ICD codes change, provider payer policies change, clinical guidelines change. So although we are using FHIR, which is giving us the structure for the data, but it's not giving us the meaning for the data. So you have this semantically fragmented data, which is dangerous. So we needed a layer for normalization to bring in all the database, all the data feeds which are different, to normalize them so we can provide proactive insights to the caller. So we know speed without trust is dangerous. So is the trust without speed is a bottleneck. So we needed a system which has a good synergy between these two aspects. So we adopted a philosophy of routing by trust rather than routing just by the workflow. So as an example, if you get a call which is a simple address lookup and we know we have the latest and greatest information, so AI agent can simply reply to the caller. However, if we get a reply from another caller which has a slight ambiguity in the information, and AI system is able to inquire the system to get the latest and latest and greatest data, and then able to provide the information without routing it to the human being. But if you have a scenario where you have a lot of discrepancies in the information, so that call can be routed to your human being for further analysis. So just like humans, AI agents also forget. But unlike humans, they don't complain when they forget, and they continuously provide wrong information very confidently. Uh, and, and we know in our ecosystem, there, you know, there are changes happening, whether it's guidelines or the ICD codes or the formularies. So we need to build a system where we are managing drift proactively before our members and our patients are able to detect those. So whether it's through the override rate tracking, or outcome correlation, and also keeping in mind that we are keeping track of all the latest and greatest changing happening in the ecosystem. So continuous monitoring and updates to the system to identify the drift before our members and our patients find out is very vital. So few of our learnings were that we were not limited either because of the model and or the AI algorithms. We were limited because of the access to the data and to get the recency of the information which we have. So it's very important for us to bring in, as much as we bring in availability of data into our design consideration, bring in the lack of availability of data into our design consideration, so our systems are able to manage those situations and mitigate accordingly. So another important thing was not just about delivering the information, but focusing on how we say it versus what we say. So in first, I would say 3 to 4 months, we were able to improve the customer satisfaction by about 20%, and we were to reduce the duration of the call by about 30%. And of course, we achieved the goal of zero hold time, and callbacks also reduced by the tune of 30% or so. Any open for questions now? Have you had similar experience in call centers anywhere? Okay. But I'm sure some of these concepts are universal. It could be implemented anywhere and everywhere. I think that's it then. Thank you, everyone.